Okay, so today we're going to be looking at classifications of solutions. So far you've seen that there's only one solution to each equation, but that's not really true. There are times when you're going to see that there are multiple solutions or no solution to an equation. So let's check it out. There are three classifications of solutions to equations: one solution, no solution, or infinitely many solutions. Equations with no solution will, after being simplified, have coefficients of x that are the same on both sides of the equal sign and constants that are different. So take a look at the examples. Here we have the coefficients 3x and 3x that are the same, and constants -5 and +5 different. So if we were to solve this, it would have no solution, would not have an answer. In the second example, we have 8x and 8x, the same, but -17 and +15, different. So again, this would wind up being no solution, and we'll see why in a minute. Equations with infinitely many solutions will, after being simplified, have coefficients of x and constants that are the same on both sides of the equal sign. So both sides are equivalent. They look the same. So in this case, 3x and 3x are the same. -5 and -5, also the same, exactly the same thing. In the second case, +8x and +8x are the same, and -17 and -17 are also the same. So it is equivalent, just twisted around. All right, so let's see how we solve these types of problems. Let me prove how this works. All right, so solve each of the following equations for x and classify as having only one, none, or infinitely many solutions. So for number one, we have 7x minus 3 equals 5x plus 5. So just like we were doing when solving with variables on both sides, I want to subtract 5x from both sides. I get 2x minus 3 equals 5. Then I want to add the constant to both sides. Plus 3 plus 3, I get 2x equals 8. Then divide by 2, which is the coefficient, and x equals 4. I have one answer. I was able to solve for x, so this has one solution. And notice in the beginning of the problem, the 7x and the 5x were different. All right, number two. Here again, I want to get the x values together. So if I subtract 7x from both sides, they both cancel out, leaving me with -3 equals +5. Now, I know -3 does not equal 5. Therefore, this equation has no solution. It cannot be solved. There's no way to subtract 3 from 7x and add 5 from 7x and get exactly the same answer. Okay, so an equation like that has no solution. All right, let's take a look at the next one. Number 3. Again, we want to take 7x away from both sides, leaving me, because they both cancel out, with -3 equals -3. Since those two are exactly the same, any number will work for x. This has infinite solutions. Okay, so I can plug in any number and it will work. If I plug in 2, 7 times 2 is 14 minus 3 is 11. -3 plus 7 times 2 is also 11. If I plug in 5, 7 times 5 is 35 minus 3 is 32. -3 plus 35 is also 32. Any number will work. So infinite solutions, because both sides are essentially the same. 7x minus 3 is the same as -3 plus 7x. Number 4, start by getting those x's together. Opposite of -8x is +8x. Those cancel out, and I'm left with 15 equals 15. Again, exactly the same thing. Therefore, I have infinite solutions. And if I'm looking at the top, okay, -8 and -8 are the same. +15 and +15 are the same. Both sides of the equation are exactly the same, resulting in infinite solutions. All right, so determine what kind of solutions you expect the following linear equations to have. Transform the equation into a simpler form if necessary. So now we're going to make these a little bit harder. The point again is to figure out if there's one, none, or infinite solutions by simplifying the problem. All right, so in number 7, I've got a lot of combining like terms to do. 11x minus 2x is 9x plus 15 equals 8 plus 7 is 15 plus 9x. Those look exactly the same. If I subtract 9x from both sides, I get 15 equals 15. So this has infinite solutions. The symbol for infinite looks like an 8 on its side if you would like to just draw that instead. So you could either write infinite or draw the symbol. All right, number 8. We've got to do a little work first. Let's distribute the 3. 3x minus 3 times 14 is 42 plus 1 equals negative 4x plus 5. So that's 3x minus 41, negative 42 plus 1, equals negative 4x plus 5. Now the x's are not the same. So right here, I know that my answer is going to be one solution. If I add 4x to both sides, I get 7x minus 41 equals 5, which is a solvable equation. So this is one solution. All right, let's keep on going. You're going to do 9 and 10 on your own. I'm going to do 11 and 12 with you. They're getting a little bit harder. You can come back to 9 and 10 later. So now on this side, I still have 5 minus 3 halves x. I can't simplify anything, so I'm just bringing it down. Equals 9, and distribute the negative 1/4. Negative 1/4 times 6 is negative 6/4 x. Negative 1/4 times 16 is like doing 16 divided by 4, so it's negative 4. All right, some more I can simplify. Well, 5 minus 3 halves x now equals 9 minus 4, which is 5. And 6/4 simplified is 3 halves x. And look, both sides are exactly the same. Therefore, this is also infinite. All right, making it a little bit harder. Still dealing with lots of fractions. 3/4 x minus 9 equals 12 plus, distribute the 2/3. Now, when I'm multiplying a fraction by a fraction, I multiply the numerators, I multiply the denominators. 2 times 9 is 18, over 3 times 8 is 24, x minus 3 divided by 3 is 1 times 2 is 2. Simplify it further. 3/4 x minus 9 equals 12 minus 2 is 10 plus, well, what goes into 18 and 24? 6. 18 divided by 6 is 3, and 24 divided by 6 is 4. So I have 3/4 x again. That hint that there's 2 3/4, positive 3/4 tells me that this is either none or infinite. The negative 9 and positive 10 tell me that this is going to be none. If I subtract 3/4 x from both sides, I'm left with negative 9 equals 10. So there is no solution. The abbreviation for no solution is a 0 with a slash through it. No solution. Okay, you're going to try 13 and 14 on your own, and the other two that we missed before. Make sure you're checking in with me to prove that you've got it right before moving on to your exit ticket.